23. Number 23. Determine the number of atoms and the mass of zirconium, silicon, and oxygen found in that many moles of zircon, which has a chemical formula of ZrSiO4. Now, that's a common name, zircon, or a geological name, something like that, because clearly this would be zirconium silicate or something, persilicate or something like that, right? All right, so we set this up, right? We are provided how many moles? What are we after?
Um, Atoms and the mass, though, of zirconium, silicon, and oxygen found in that.
All right. So determine the number of atoms. Let's do that first. Let's do atoms of zirconium, silicon, and oxygen. So if I say atoms of zirconium. Now, if I look at the chemical formula ZrSiO4, ZrSiO4, right? And I'm given a number of moles of this material, right? Um, if I have that many moles of this, I'll also have that many moles of zirconium and that many moles of silicon. How many moles of oxygen will I have?
That many moles?
No, I'll have 4 times as this. Can you see that? Because this is kind of like a cookie, right? So I have a cookie. This is one of my zirconium silicate oxygen cookies. And in here, each one of these cookies has a silicon, has a zirconium, and has 1, 2, 3, 4 oxygens, right? That's what this is. Now I have 0.3384 moles of this, right? And every one of these, I have one of those. I can see in this chemical formula, for every mole of this, I have one of those, and one of those, and four oxygens. Okay? So when I solve for my atoms of zirconium, it's going to be equal to the number of atoms of silicon, and I can just multiply it by 4 to find the atoms of oxygen. So what I'm going to do here is I'm going to solve for zirconium and then recognize that that's the same answer for silicon and just times by 4 to get the oxygen. Okay? So how do I do that? Any ideas?
Well, what do you mean?
I'm going to go from starting with moles of zirconium silicate and do what?
Um, Go to moles of silicon,
Or moles of zirconium, right?
zirconium.
Yeah, okay. So if I go moles of ZrSiO4, now I knew that had to be because that's what I have here, right? And now I'm going to go to moles of zirconium. And the ratio is 1 to 1. So for every mole of this stuff, I have 1 mole of zirconium. Now how do I go from moles of zirconium to atoms? What's the relationship?
How many atoms are in a mole?
That's right. And that's all I have to recognize. Do you remember what it is?
Well, it's that number, right?
That's right. 6.02 times 10 to the 23rd.
Yeah, that one.
6.02 times 10 to the 23rd zirconiums for every mole of zirconium, right? And again, this is where a mole is kind of like a dozen. This is the number that there are in a mole of stuff. A dozen, if this was a dozen of these, it'd be 12, but if it's a mole, that's the number. Okay? So, calculator, 0.3384. That's how many moles of zirconium I have, times 6.02 times 10 to the 23rd. All right. And that equals 2.037 times 10 to the 23rd. All right. That's the atoms of zirconium. That's also the atoms of silicon. And this number times 4, right, is the atoms of what?
Oxygen.
That's right. That's how many atoms of oxygen there are. All right, now it says number of atoms and the mass of all of these. So if I want to know the grams of zirconium, if I want grams of zirconium, and I start with 0.3384 moles of zirconium silicate or zircon, Can I get from moles to grams there?
Well, moles of zirconium silica, whatever it is, has to go down below, right?
That's right. I need the units that I have up here, down here, ZrSiO4.
And then you can go moles of zirconium.
That's right. Every mole of this gives me 1 mole of zirconium. Then what?
Then you can just go moles to grams.
That's right. I can go moles of zirconium to grams of zirconium. Now what numbers go in there?
Isn't that just what's on the periodic table?
That's right. Good job. So if I bring up my periodic table here, I find zirconium 91.22 is the number of grams, 91.22 number of grams for every mole. So I start off with my 0.3384 times my 91.22, and that is how many grams, 4 significant figures, 30.87 grams of zirconium. Okay? If I wanted to get grams of silicon, I would do the same thing, right? Let's get this piece of paper moved up out of the way a little bit, give us a little more space. If I want to go grams of silicon, right? Starting with, again, 0.3384 moles of zirconium silicate, oops, IO4. What would I go there?
Moles of silicon.
That's right. So I start with, again, what I have here, moles of ZrSiO4, and I want to go to moles of silicon. And it's just 1 to 1.
And then you go moles to grams.
Good. Moles of silicon to grams of silicon. And that number for silicon,
Is it 32?
I don't think so. That's sulfur. It's 28.09.
28.09.
All right. 28.09 times that number there. This is, again, just one that looks like a 2. It's just 1 zirconium silicate, and then 1 mole of silicon. Okay. So this times the 28.04 will give us the 28.09. Will give us the grams of zirconium. All right. Grams of oxygen, very similar, right? If I want grams of oxygen, I start with my 0.338 for moles. Moles of ZrSiO4, one of them, and moles of oxygen. Is it just 1 mole of oxygen?
No, it's 4.
That's right. This time it's 4 moles of oxygen. And if I go from moles of oxygen to what?
Grams of oxygen.
Grams of oxygen.
And that's 16.
16. That's on the periodic table as well. All right. And this will tell me how many grams of oxygen. 0.3384 times 4 times 16. 21.66 grams of oxygen. All right. Very good. That's number 23.
That took a long time.
Yeah, but we learned a lot, right?
I guess so.
All right, number 24. Determine which of the following contains the greatest mass of hydrogen. So we got 1 mole of that, 0.6 moles of that, or 0.4 moles of that. Which one contains the greatest mass of hydrogen? Well, which one contains the greatest moles of hydrogen?
The first one has 4 moles of hydrogen.
Very good. 1 mole of this. If I want to know how many moles of hydrogen, and I start off with 1 mole of CH4, I can go from moles of CH4 to my moles of hydrogen. And there's 4 for each CH4. It looks like this. 1, 2, 3. For each CH4, there's 4 hydrogens. So if I have a mole of these, I have 4 moles of the hydrogens. You can play that game with dozens as well. If I have a dozen of these, I would end up with a dozen hydrogens. Okay? So, 4 moles of hydrogen in the first scenario. The second one is 0.6 times 0.6, because I have 6 moles of hydrogen, but I only have 0.6 moles of it. So 3.6, so that's less than 4. And the third one is 8 times 0.4. So 3.2. So the first one contains the most moles of hydrogen. Therefore, it's also going to contain the most grams of hydrogen. If I say I have 4 moles of hydrogen, and I would like to know how many grams of hydrogen that is.
It's just 4.
Right, because why?
Because each mole of hydrogen has a mass of 1.
Very good. So 4 moles of, 4 moles of hydrogen. I'm going from moles of hydrogen to grams of hydrogen. 1 gram per mole, to be precise, 1.008, but that's all right. Okay. All right. So, number 25, determine which of the following contains the greatest mass of aluminum. Okay. So we got 122. 122 grams of aluminum phosphate. AlPO4. All right, 122 grams of aluminum phosphate, and I want to know how many grams of aluminum there are, right? Which of the following contains the greatest mass of aluminum? Is that right?
Yeah, that's right.
So if I have that, how am I going to get that to grams of aluminum?
You got to go to moles, don't you?
That's right. You have to go to the land of the moles because this statement here, AlPO4, is in a molar ratio. 1 mole of aluminum, 1 mole of phosphorus, 4 moles of oxygen. So what I do is I go from grams, I always know I have to start with what's up there, down here in my conversion factor, grams to moles of aluminum phosphate. And then after I have moles of aluminum phosphate, I can go to moles of aluminum. And then after I have moles of aluminum, I can go to grams of aluminum. All right?
Well, where do you get those numbers?
This one, do you know where you get this one?
That's the periodic table, how many grams there are per mole.
That's right, I'm looking at it there. It's 26.98. 26.98 grams for every mole, all right, of aluminum. How about this one?
Moles of aluminum phosphate. Oh, is that just 1?
That's right, every mole of this aluminum phosphate, there's 1 aluminum in it.
Okay.
Now how about this one here?
Is that the molar mass?
That's right. I'm wondering if I have 1 mole of this, how many grams do I have? So that's the molar mass, right? So I'm going to bring up a Google page here. What's the molar mass of aluminum phosphate?
According to Wikipedia, aluminium phosphate is a chemical compound. In nature, it occurs as the mineral berlinite.
Berlinite. What a pretty name. Oh, so I'll put in there 122 grams per mole. So 122 divided by 122 times the 26.89. That's nice. They gave me exactly 1 mole of that material. All right. I wonder if that's what they're doing for all these. So there I found how many grams are going to be in this. Let me finish that up in the calculator here. 122 divided by 122 times 26.98. So 26.98, I have that many grams, which is a mole, and that many moles of aluminum because I had 1 mole of this to start out with. So that makes sense. So then let's look at aluminum chloride. What's the molar mass for aluminum chloride? You think it's 266?
Probably.
What's the molar mass for aluminum chloride?
According to Wikipedia, aluminium chloride,
It's half
also
as
known
much.
as aluminium trichloride, is an inorganic compound with the formula aluminium chloride.
Okay, so what does that tell us?
266. That's twice as 133.
So that tells us we had 3 moles, or 2 moles, right? 2 moles of that material. So that means that, oh, look at this though. There's 2 aluminums for every unit of this material. So if I want to know grams of aluminum, and I have 266 grams of aluminum chloride, wait, this is Al2Cl6. 6.